Hello students, myself Lucknesh Kumar, assistant professor in information technology department in AKGEC. Today I am going to deliver a lecture on entity relationship model. The subject code, it is a part of database management system, and the subject code for the subject is KCS 501. So ER model is a very important topic in AKTU, and every time we get a question in the university exam. So we continue with design phase. The initial phase of database design is to characterize fully the data needs of the prospective database users. The users have given some requirements, and we have to collect those requirements to deliver the system as desired by the user. So to make that happen, we want to design that system using ER model. Next, the designer chooses a data model, and by applying the concept of the chosen data model, it translates these requirements into a conceptual schema of the database. We get the conceptual design of the requirements given by the user. The fully developed conceptual schema also indicates the functional requirements of the enterprise. So that will give you the fully functional requirements as required by the user. So after getting the conceptual design, we may add or update the things if the user demands more in the, or the additional features can be added for a system. In a specification of functional requirement, users describe the kind of operation or transaction that will perform on the data. So if the requirements are clear, then there are various operations can be performed on those requirements. Next is that the process of moving from, if we get that abstract data model, to the implementation of the design proceeds in two final design phases. So we have mainly two design phases on which we proceed. First one is the logical design, and second one is the physical design. In the logical design, it decides mainly the database schema, and the database design requires that we find a good collection of relation schemas. So as the requirement suggests, we want some schemas to be implemented in the database. That decision which schema has to be selected, it depends on the business decisions also, like what attribute should be recorded in the database. That will be the question. So if the entity is finalized, then what attribute should be added in the database to get the best raw data to fulfill the requirements. And another reason for a logical design is computer science decision. So what relation schema should we have, and how should the attributes be distributed among the various relation schemas. So once the things are clear, we can get the entities and the attributes, but those attributes should be distributed in such a manner that it would be utilized in a better way. Next is the physical design, that is mainly it shows the physical layout of the database. So various design approaches we follows. One of them is entity relationship model. This models an enterprise as a collection of entities and relation. Entities and relation. Okay. Entities and relationships. Entity, what we call entity. Entity is a thing or an object in the enterprise that distinguishable from other objects. Means how, if we categorize something into a group, we call them a entity. It can be an object or a thing. These entities can be described by various set of attributes. Relationship another part of the entity relationship diagram or model is relationship. It is an association among several entities. So, first we have to select the entities that are real world object, okay, a group of objects or a group of things that can be categorized into a single name, we call it as a entity, and those entities can be integrated among themselves using relationship. So, they have some association, so that they can be used in a used for the system for various functionalities. Represent diagrammatically by an entity relationship diagram, and this whole thing is represented diagrammatically using entity relationship diagram. And second approach is, one of the next approach is normalization theory, but we are not going to discuss normalization theory here. But what is normalization theory? It formalizes what design are bad and test for them. Mainly we select the entities, we select the attributes, we select the relationship among the entities, and we design the system. But for normalization point of view, we select which entities or relationship is bad. We can break it down into smaller units if it is not utilizes in a better way. So, we continue with the ER model, database modeling. The ER data model was developed to facilitate database design by allowing specification of an enterprise schema that represents the overall logical structure of a database. The overall logical structure of a database can be shown by ER model by allowing all the specification given by the user for any enterprise. The ER model is very useful in mapping the meaning and interactions of real world enterprise into a conceptual schema. So, we all collect them and we view them using a conceptual schema. Because of this usefulness, many database designer or design tools are available that draw into an ER model. The ER data model employs three basic main concepts. It is a entity set, one is the entity set, second is the relationship set, and third is the attributes. So, we discuss all one by one. The ER model also has an associated diagrammatically representation, the ER diagram, which can express the overall logical structure of a database graphically. So, first thing we discuss the entity sets. First we discuss about the entity, then come to the entity set. The entity is an object that exists and is distinguishable from other objects. It is a real world entity, means object or a thing that can be categorized or grouped into a single unit. We call them as a entity, like student or a university or employees. These are the examples of an entity. There are other examples are specific person, company, event, plant. These are all objects that exist in our real world and that can be distinguishable from other objects too. The entity set is a set of entities of the same type that share the same properties. So, mainly entity set is a set of the same type, means like person is working in some company and holding some event, and a set is called a entity set. Example, a set of all person, companies, trees, holidays, we call them as a entity set. An entity is represented by a set of attributes. To represent those entities, we need attributes. So, it describes mainly the entity. It is a descriptive properties processed by all members of an entity set. Example are instructor. Here the instructor is having ID, name, street, city, salary. So, this particular attributes will give you the information about the instructor, and the course entity are having attributes like course ID, title, credits, and this course ID, title, credits are all a part of course. In a course we give ID also, we give title also, title of the course, and some credits for that course also. And for instructor, the name of the instructor, his ID, the place he live, or the salary he was offered. So, a subset of the attributes form a primary key of the entity set, that is uniquely identifying each member of the set. So, to describe or to get the information for a particular entity, we need a primary key, and that primary key is from the attribute or a set of attributes. Okay. A subset can be uniquely describe a entity, like unique number, like here we have for an instructor we have ID. From the ID we can get all the details of the instructor, and for the course ID we get it is a primary key here. Next is the entity sets. So, here we says that instructor, two tables are given, one is having instructor ID and other column is a instructor name. For the student we have the student ID and the student name. So, here this is a entity set for instructor and this is a entity set for student. Relationship set. A relationship set is an association among several entities. So, various entities, if we want to get the information for a particular enterprise, we join the entities with a relationship. Like a example here that Platiler name student entity with a student ID 44553, and Einstein is a instructor. This is a instructor entity. So, both the entities will be collectively used with a relation. So, they are having some relation among them called the advisor, and that is a relationship set. A relationship set is a mathematically relation among various entities. It should be equal to or mainly it is having more than one, or should be equal to two entities. So, we need two entities to make some relation among them, each taken from entity sets. So, here E1, E2, En belongs to E1, okay, and from entity set E1, E2, En we get a relationship. That relationship will be like 44553 222, that is the instructor ID, and for a particular student the ID is 44553. It all belongs to advisor. Advisor is a relationship set. Advisor is a relation and this is called a relationship set. So, we got more about relationship set, advisor. So, here two entities are given, entity set are given, that is instructor and the student. Instructor having some student course instructor ID and the name of that instructor, and the student is also having student ID and his name. So, all are connected with each other using the advisor relationship set. An attribute can also be associated with a relationship set. Here we are using a relationship set. An attribute can also be used, like for instance the advisor relationship set between entity set instructor, this is a entity set, and student entity set may have the attribute date. This is a attribute set date. So we use it we use a attribute to show relationship between a two entity set. So next is the degree of a relationship set. Here we discuss mainly about the binary relationship. In a binary relationship, it involves mainly two entities. If two entity sets are involved, we said it is of degree 2. More relationship sets in a database systems are binary. Maximum relationships are binary in nature only. Relationship between more than two entity sets are very rare, but it can be possible. So like example, student works on some research projects under the guidance of an instructor. Relationship project guide. This is a relationship project guide. It is a ternary relationship between instructor and student and project. So we can say that a student can work on some project under the guidance of some instructor. Mapping cardinality constraints. So once we want to join or build a relationship between two entity sets, we follow some mapping cardinalities also. So to express the number of entities to which another entity can be associated via a relationship set. So how many entity sets can be connected and the number of entities to which another entity sets can be associated, that can be described using the relationship set. It is most useful in describing binary relationship sets. If a relationship set is binary, that it is mostly used and it is also useful in that also. For a binary relationship set, the mapping cardinality must be of the following type. One can be one to one, one is one to many, many to one and many to many. These are the four mapping cardinality we use for a to show an association between two entity sets from using some relationship. So mapping cardinalities. Here we can see that A and B are the two entity sets and they are connected to each other or associated with each other using some relation. Here in A diagram we see it is a 1 to 1 cardinality, like one is connected to only one entity set is connected to the entity set of another entity, like A1 is connected to V1, A2 is connected to B2, A3 is connected to B3, and some can be left out, but if it has to be connected, then it should be connected to only one to one relation cardinality we show using this diagram. In the next diagram we show one to many cardinality, like A1 is connected to B1 and B2, A2 is connected to B3 and B4 and A3 is connected to only B5. So one is connected to many entities set in a associated entity. So the point to be noted here is some elements in A and B may not be mapped to any elements in the other set, like we see here A4 is not connected to anything. Next we discuss about many to one. In this diagram we can see many entity sets of A are connected to only one entity set of B, like A1 is connected to V1, A2 is connected to B1 only, A3 is to B2, A4 and A5 are connected to A3. This is many to 1, many to 1. Okay, here many to many, anyone can be associated with any, like A1 is connected to V1, A1 is connected to B2 also. Likewise, B1 is also connected to A1 and it is also connected to A2. So, we have a association many to many here. Okay. The things to be noted here are some elements in A and B may not be mapped to any elements in the other set. Okay. Some cannot be mapped. Okay. Next, we will discuss about some complex attributes. So, we have attributes that describe the entity. So, we have various types of attributes too, like simple and composite attributes, single valued or multi-valued, attributes. For a multi-valued attributes, we can say, like single valued, we can say name. Name can be, everyone has a one name only. We can call a nickname also, but it is a distinct category. Okay, but single valued, like date. Okay, date of birth. Everyone is having only one date of birth. So, it is a single valued. In multi-valued, a person can have, or a student can have multiple phone numbers. So, it is a multi-valued attributes. So, to represent those multi-valued attributes, we have different system for it. Like for phone numbers, we cannot describe them in a single domain. In a single domain, we only put one phone number. We cannot use comma to insert another phone number in the same category. Derived attributes. Derived attributes are the attributes that are derived from other attributes, like age. Age, it can be derived from date of birth. We can have another example also. Okay, from date of joining for an employee and date of resignation for an employee category. Okay, so we can count the experience also from that. That is also can be derived from date of joining and date of resignation. If we follow some employees data or a employee entity, for those attributes we find the experience field. If we have, this is derived from the date of joining and date of resignation. So, here also from date of birth we can derive it as a age. Age can be derived from date of birth. Domain, the set of permitted values for each attribute. So, only some permitted values can be inserted into a table or in particular attribute column. Okay. So, that is called the domain. If a domain is, all the domain are fixed, we cannot insert any value in that domain. Only the permitted values that an attribute can take will be inserted, or others will not be inserted. Composite attributes, like we categorize, it is a collection of various attributes. Like for a name, we can have first name, middle name, last name. We can say that it is a composite attributes, as it can be categorized into various other sub attributes. Okay. Component attributes, if we have some composite attributes, and then we can also refine the thing like street number, street name, apartment number. This can be, this will represent as a component attribute. Redundant attributes, here we see some attributes are reported in every table, or more than one table, more than one entity. Like suppose we have entity set instructor with attribute ID, name, department name and salary, and department with attribute department name, building and budget. So, In both the entity sets, we see that department name is common here, because we need that data to get the information of the instructor. A department will be in a department, it is the primary key. We model the fact that each instructor has an associated department using a relationship set instructor department. Like every instructor will be connected to some associated with some department. So, to get the information about the department from the instructor table itself, we select department name here also, and for a different category department, it is a primary key in a department entity, it is represented here also. The attribute department name appears in both entity sets. Since it is the primary key for the entity set department, it replicates information present in the relationship and is therefore redundant in the entity set instructor and should be removed, but we are not removing it, because if we remove it, we cannot associate both the entity sets using some relation. But when converting back to tables, in some cases the attribute gets reintroduced, as we will see later. We will follow it later, that why we are using duplicate entries, but it is called redundant attribute. Weak entity sets. It is being asked in many AKGEC question papers and in competitive exams also. So, what is weak entity sets? Consider a section entity which is uniquely identify a course ID, semester, year and section ID. For a section ID entity, we have course ID, semester, year and section ID. So, why we are having course ID here? Section ID and course ID are more or like the same only. Clearly, section entities are related to course entities. Suppose we create a relationship set section and course. If we create a relationship set section course, between entity set sections and course, we have course ID common. It is redundant attribute. Note the information in section course, it is redundant since section already has an attribute course ID which identifies the course with which the section is related. So, the section ID is used, it is having a section ID as a primary key in section and course ID is the primary key in course, but section ID is using course ID to get the information. One option to deal with this redundancy is to get rid of the relationship section course. If we remove the section course, duplicate entity will be removed. However, by doing so, the relationship between section and course become implicit in an attribute which is not desirable. We cannot associate both the entities, the relationship cannot be shown, it become implicit. So, we cannot remove the section course relationship set. Every weak entity must be associated with an identifying entity, that every weak entity should be associated with an identifying entity, means the identifying one where it is a primary key. That is, the weak entity set to be existence dependent on the identifying entity set. So, it is a existence dependent on the identifying entity set, like section ID depends on the course ID. So, if course ID is not given, the section will have no existence. The identifying entity set is set to own the weak entity set, that it identifies. So, the relationship associating the weak entity set with the identifying entity set is called the identifying relationship. So, if we have a relationship in them, then that relationship is called a strong and a weak entity set is having a relationship, then that relationship is called identifying relationship. Here we have to note that the relation schema we eventually create from the entity set section does have the attribute course ID for reasons that will become clear. We will discuss it later. Even though we have dropped the attribute course ID from the entity set section, if we remove the section ID from the course ID from the section attribute, we we cannot get the information. We will discuss it that in later part. So these entity sets can be represented graphically as mainly it follows. It is a rectangular represent entity sets and attribute listed inside. These are the attributes, and the underlined indicates the primary key attributes. Relationships can be described like diamond represent relationship set. Diamond, here the instructor and the student are entities are associated with the relationship advisor, and the ID is the primary key in both the entities. Relationship set with attributes, we can for identifying entities can be also be given on the relationship, like advisor, on what date the advisor meet the student meet the instructor, or on which date the instructor instruct the student. Roles, various roles can be played. The entity set of a relationship need not to be distinct. We discussed it can, but it is we says that two entities will be associated with using a relation, but it can be associated with itself also. Each occurrence of an entity set plays a role in the relationship. The label course ID and prerequisite ID are called roles. Cardinality constraints, how we show cardinality in a ER model. We express cardinality constraint by drawing either a directed line or satisfying one, or an undirected line using single line signifying many between the relationship set, the entity set. Here one-to-one relationship between an instructor and a student. How we show the one-to-one relationship? Like if we use single arrow here, then it shows one-to-one relation. A student is associated with at most one instructor by the relationship advisor. A student will have only one instructor. A student is associated with at most one department via student department in another table. One-to-many relationship. One-to-many relationship between an instructor and a student. How we show that those relationship? An instructor, here one side, for an instructor side it is showing arrow, and another side we show is normal line. An instructor is associated with several student via advisor. The one instructor can advise many students here, including 0 also. And student is associated with, or a particular student is associated with only one instructor. Many to many relationship. Here a instructor can advise many students, and an student can take advice from many instructor. Here instructor is associated with at most one student via advisor, and a student is associated with several instructor via advisor. Many to many relationship. An instructor is associated with several student via advisor, and a student is associated with several instructor via advisor. In the previous one, here the arrow is given, so it can have at most one student. A instructor can teach only one student via advisor, but a student is associated with various instructors. This is called the many to one relationship. And in many to many, several students can associated with several instructor, and several student can be associated with several instructors, and instructor can associate several students. Total and partial participation. This is also very important topic. Here the total participation is indicated by double line. Here total participation is indicated by double line. Every entity in the entity set participates in at least one relationship in the relationship set. It is called the total participation. Like here every student must have a instructor. No one should be left blank. Participation of student in advisor relation is total. Here we see it is total. Like every student must have an associated instructor. Partial participation is some entities may not participate in any relationship in the relationship set. Like participation of instructor in advisor is partial. Like not all the teacher or not all the instructor will teach the student. So it can be left blank. So it is a partial participation. Notations, where is notation for expressing complex constraints, like a line may have an associated minimum cardinalities shown in the form L to H, where L is the minimum and H is the maximum cardinality. A minimum value of 1 indicates total participation and a maximum value of 1 indicates that the entity participates in at most one relationship. Like a maximum value of star indicates no limit. So here we see a diagram. Here 0 to 1, 0 to star is given and here 1 to 1 is given. So in this diagram we can get the information like instructor can advise 0 or more student. Student, a instructor can advise 0 or more students. Here it is indicated that student must have one instructor advisor but cannot have multiple advisors. Only one advisor will be given to one student. So other how to express entity with complex attributes. Here ID, name, address. In address we have city, street, and in phone number, date of birth, age. These are other attributes of instructor. We can describe here in this way. Weak entity set. To describe weak entity sets, in here diagram a weak entity set is depicted by a double rectangle. Like this is a weak entity set. We underline the discriminator of a weak entity set with a dashed line. This is dashed line. Okay. The relationship set connecting the weak entity set to the identifying strong entity set is depicted by a double diamond. So this is a weak entity set. Total participation is given here, and this double diamond will set the for us it is connecting the weak entity set. So primary key for this section can be course ID from the strong entity set, then all the attributes of the weak entity set: course ID, section ID, semester, year, section ID, semester, year, and the course ID from the strong entity set. ER diagram for a university enterprise. This is the diagram to get the clear view what we have studied till now. It is for a university platform in the system. So here we see we have instructor, student. These are the entities here: instructor, student, department, section, classroom, time slot, courses, and each are connected by some relationship associated with some relation. This is having total participation. Here one course can be given, one course for each section. Okay, time slot is given. This is also having weak entity set type of thing here. Okay, this is also total participation. Here also we say total participation. Okay, this dotted line, it is derived we can take grade from section for the students, and instructor teaches section. So, section should have, all the sections should have instructor. So, it is given total participation. So, students, this is the diagram. So, that is all for today. We will discuss more about AR diagram in later sections. Thank you.